Episode 2, Unit 1. Title of the Radio Enable Learning course is Energy Physics. In this episode, first we will discuss about renewable energy resources. Renewable energy sources include both direct solar radiation intercepted by collectors, that means solar and flat plate thermal cells, and indirect solar energy such as wind, hydropower, ocean energy, and biomass resources that can be managed in a sustainable manner. Geothermal fields tapped with present drilling technology have a finite life but are sometimes considered renewable for planning purpose. Traditional methods of using biomass and derivatives such as wood and charcoal are highly inefficient. In contrast with modern techniques, proper management sustain yield fuel wood plantations and efficient production. If broadly interpreted, the definition of renewable resources also includes the chemical energy stored in food and non-fuel plant products, and even the energy in air used to dry materials or to cool, heat, and ventilate the interior of buildings. From an operation viewpoint, the correct way of treat renewable energy is as a means to reduce the demand of conventional energy forms. Thus, in performing economic and financial analysis, there is no real distinction between renewable energy technologies and those designed to improve the efficiency of conventional energy use. A further point is the cost of effective approaches to energy efficiency ranging from no or low cost measures, air in boilers, shutting down equipment when not needed, to systems requiring moderate capital investment such as heat recuperators, boilers replacement, or very needed unit can improve the financial and economical flexibility of renewable as well as conventional energy system. Improvements in the efficiency of energy use can be teamed with variety of energy supply technologies, and these facts must be recognized when the relative economics of renewable and conventional energy system. 3 independent primary sources provide energy to the earth: the sun, geothermal force, and planetary motion in the solar system. In particular, direct solar radiation represents an enormous resource for a modern technological civilization. However, human capacity of harness these natural flows of energy to perform use work depends largely on the economic usage of the required conversion in the comparison with fossil fuel options and the extent to which large-scale application affect food production, climate, and ecology. Advantages of renewable energy. Even though renewable options are not likely to supply substantial amount of energy to developing countries over the short term, they do have these advantages. Renewable energy is an indigenous resource available in the considerable quantities to all developing nations and capable in principle of having a significant local, regional, or national economic impact. The use of renewable energy could help to conserve foreign exchange and generate local employment if conservation technologies are designed, manufactured, assembled, and installed locally. Several renewable options, financially and economically competitive for certain applications, such as in remote location where the cost transmitting electric power or transporting conventional fuels are high. In those well endorsement with biomass, hydro, or geothermal resources. Because conventional technology turns to flexible and modular, it can be usually be rapid deployed. Other advantages of modulator over very large individual unit include easy in adding new capacity, less risk in comparison with investment, lower interest on capital because of shorter lead times and reduced transmission and distribution costs for rural locations. Rapid scientific and technology advantages are expected to expand the economic range of renewable energy application over the next 8 to 10 years, making it important for international decision makers and planners to keep abreast of these developments. Obstacles to the implementation of renewable energy system. Experience with renewable energy projects in the developing countries indicates that there are number of barriers to effective development and diffusion of this system. Among these are documentation and evaluation of past experience, validate field performance, data, and lack of clear priorities for future work. Weak or non-existent institutions and policies to finance and commercialize renewable energy system. With regard to energy planning, separate the completely uncoordinated organization are often responsible for petroleum, electricity, coal, fuel, wood, renewable sources, and conservations. Technical and economical uncertainties in many renewable energy systems, high economic and financial costs for some systems in comparison with conventional supply options, and energy efficiency measures. Prospects of renewable energy sources. The one new source of energy that promises to replace oil and gas and ultimately coal is different kind of fusion reactor, the sun. The total amount of incoming solar energy absorbed by the earth and its atmosphere in 1 year is 3.8 into 10 to the power 24 joule, is equivalent to 15 to 20 times the amount of energy stored in all the world's reserves of recoverable hydrocarbons. Indeed, if just 0.005% of the solar energy could be captured using fuel crops, specially designed buildings, wind and water turbines, solar collectors, have energy converters and the like, this would supply more useful energy over the year than it's currently obtained by burning fossil fuels. Unlike capital energy resources, renewables cannot be exhausted. The only limitation is the rate at which they are used. It is not possible to any particular reservoirs of energy such as column of moving air or falling water faster than it is replicated. Renewables already supply a major part of the world energy needs. Biomass, for the example, accounts of the about 1/7 of all fuel consumed and supplies over 90% of that used in some third world countries. Hydro generates 1/4 of the world's electricity and more than 2/3 of that used in over 35 countries. And the sun contributes directly to space heating in virtually all buildings through the walls and windows, although precise estimates of the size of this contribution are not available. However, over the last 2 decades, there has been emerging interest in the renewable energy from the more industrialized nations, and this has led to growing capital investment. Renewable energy technologies are in many ways more attractive than most conventional energy technologies. They can be matched in scale to the need and can deliver energy of the quality that is required for a specific task, thus reducing the need to use premium fuels or electricity to provide low-grade forms of energy such as hot water, that means, which can be supplied in many other ways. They can often be built on or close to the site where the energy is required. This minimizes transmission costs. They can be produced in large numbers and introduced quickly, unlike large power stations, which have long lead times, often 10 years or more. Rapid planning and construction lowers unit cost and allows planners to respond quickly to changing patterns of demand. The diversity of the systems available also increases flexibility and security of supply. In contrast, over dependence on imported fuels makes a country more to political pressures from producers, nations, and multinations. Generic faults in power plants, serious breakdowns, industrial action, or simply bad weather can jeopardize the supply of electricity. While there are physical and environmental risks associated with construction and operation of renewable energy technologies, as there are with all energy conversion systems, they tend to be relatively modest by comparison with those associated with fossil fuels or nuclear power. The failure of a solar panel or a remotely sited wind turbine or wave energy converter might involve temporary inconvenience, but it will not, as a rule, nor cause lasting damage. The most serious consequences could be those associated with such events as the failure of a large hydroelectric dam, fire in a biomass plantation, or explosions of methane digester. Next, we should know about world renewable energy resources. Solar energy. Total solar radiation absorbed by the earth and its atmosphere is 3.8 into 10 to the power 24 joule per year. Application: low temperature heat, that means space heating, water heater, and electricity. Millions of solar water heaters and solar cookers are in use. Solar cells and power towers are in operation. Next one is wind. The kinetic energy available in the atmosphere circulation is 7.5 into 10 to the power 20 joule. Application: electricity and mechanical energy, that means pumping, transport. Several multi-megawatt wind turbines are in operation and many more in construction. There are a number of small wind turbines and wind pumps in use. Next one is biomass. Total solar radiation absorbed by plant is 1.3 into 10 to the power 21 joule per year. Application is high temperature heat, that means cooking, smelting, etc. Biomass, that means principally wood, accounts for about 50% of the world commercial fuel consumption. It provides over 80% of the energy needs of many developing countries. The world standing biomass has an content of about 1.5 into 10 to the power 22 joule. There are millions of biogas plants in operation, most of them are in China. Another important application is alcohol, that means transport. Several thousand million liters of alcohol are being produced notably in Brazil and the US. Production is increasing rapidly. Many countries have launched liquid biofuel programs in many countries. Next resource is geothermal. The heat flux from the earth interior through the surface is 9.5 into 10 to the power 20 joule per year. Major applications are low temperature heat, that means bathing, space and water heating. Geothermal energy supplies about 5350 megawatt of heat for use in bathing, principally in Japan, but also in Hungary, Iceland and Italy. More than a lakh houses are supplied with heat from geothermal wells. The installed capacity is more than 2650 megawatt, that means thermal. The total amount of heat stored in water or stream to a depth of 10 km is estimated to be 4 into 10 to the power 21 joule. That stored in the first 10 km of dry rock is around 10 to the power 27 joule electricity. Installed capacity is more than 2500 megawatt, but output is expected to increase more than 7-fold by 2000. Next major resource is tidal. Energy dissipated in connection with slowing down the rotation of Earth as a result of tidal action is around 10 to the power 26 joule per year. The major application is electricity. Only one large tidal barrage is in operation at Lorient in France, and there are small schemes in Russia and China. Total installed capacity is about 240 megawatt and output around 0.5. In addition, China has several small tidal pumping stations. Several large tidal schemes are being planned. Next one is wave. The amount of energy stored as kinetic energy in waves may be of the order of 10 to the power 18 joule. The major application is electricity. The Japanese wave energy research vessels, the Kaimi, has been installed capacity of about 1 megawatt. There are in addition several hundred wave powered navigational buoys. Designs after large prototype wave energy converters are being drawn up. Next energy source is hydro. The annual precipitation land amounts to about 1.1 into 10 to the power 17 kilogram of water. Taking the average elevation of land area as 840 meter, the annually accumulated potential energy would be 9 into 10 to the power 20 joule. The major application is electricity. Large hydro schemes provide about 1/4 of the world total electricity supply and more than 40% of electricity used in developing countries. The installed capacity is more than 363 gigawatt. The technically usable potential is estimated to be 2215 gigawatt or 19,000 per year. There are no accurate estimate of the number of capacity of small hydro plants currently in operation. Size of the contribution that each makes to current energy demand. Geothermal energy is included, although it is not strictly a renewable source. A practical and economic potential of renewables is order of magnitude less than the theoretical potential. However, renewables could still meet total world energy demand many times over. The perspectives studies carried out indicate substantial increase in the commercial energy requirements from now to the end of the century. The electricity generation requirements would increase from about 110 at present to about 515 by the year 2000. The requirements of oil are expected to increase from about 30 to 92 million tons and coal from 100 to 530 million tons. Coal is the most important commercial source of energy in India. The source assessment done in 1978 gives the total coal reserves of the country up to depth of 600 meter and in seams of thickness above 1.2 meter as 85,450 million tons. A significant amount of coals occur at depth greater than 600 meter and in seams of thickness less than 1.2 meter. Thus, the total reserve of coal are put at about 1,11,700 million tons. The survey and exploration for oil and gas resources are presently being conducted mainly by the ONGC and to some extent by Oil India Limited. The net recoverable reserves of oil are estimated at about 300 million tons and natural gas of 73 million cube meters. Preliminarily, assessment of hydroelectric potential indicates that the exploitable potential is about 400 of annual energy generation. Schemes with an energy potential of 40 have already been constructed and presently in operation. The bulk untapped hydroelectric potential equipment to 360 of annual energy generation is located in northern and northeastern regions, mainly along the rivers of Himalayan origin. The average load factor of electro or hydroelectric plants presently in operation is about 42%. India has modest the reserves of uranium and substantial reserves of thorium. The established uranium resources are considered capable of supporting a nuclear program and nuclear uranium of about 8,000 megawatt electron. India's thorium reserves can support a very large program of nuclear power development based on reactor technology. The intensity of use of electrical energy in the Indian economy has shown a steady increases. This trend necessity substantial increase in the share of investment. The investment made the power sector was of the order of rupees 1,54,000 million in the sixth plan around 1978 to 83. It would be difficult for the economy of sustain such increasing order of investment in the future. It is therefore essential that the demand for electricity in time of peak value and energy should be managed with a view to reduce the intensity of electricity used in various sectors. It is also essential to keep transmission and distribution losses and consumption of energy by auxiliaries in the power station to a minimum. Under conditions obtaining in India, hydroelectric power, generally the most economical source for power generation. Accelerating its development will help in achieving the twin objectives of optimizing investment and conserving energy resources. India has been following the policy of biasing its thermal power development predominantly on coal. This policy would be continued in the future also. The location of thermal power plants is being gradually shifted closer to the coal mines to reduce the energy costs required for transportation of coal. Due to the limited oil reserves, India has to depend on substantial imports for meeting its future requirements. The bulk of the demand for oil is from transport sector, and in order to reduce the pressure from this sector, it is necessary to explore possibilities of developing substitute fuel like biomass and producer gas. Accelerating the pace of electrification of rural areas and judicious pace of mechanization of agriculture could help in reducing demand for oil. Out of total non-commercial fuel, the share of the firewood is nearly 65%. The availability of animal dung and agriculture waste is likely to increase in the future due to increased agriculture production and animal population. With the popularization of biogas plants, there might be an increase in the consumption of animal dung used as fuel in the household sector. Biogas and solar energy offer the greatest scope for the development of new energy source. A number of prototype devices have been successfully developed for use of solar energy in areas like grain drying, water and space heating and power generation. These devices are presently undergoing field trials for their performance and reliability. Application of wind power for agriculture pumping with certain prototype model are undergoing field trials and evaluation. Explorations to establish the geothermal and tidal potential are in progress, but they are expected to contribute to any significant extent to the energy supplies by the turn of the century. Some important questions. What are the primary and secondary energy sources? What are the conclusions on alternate energy stages? Next one. What are the conventional and non-conventional energy sources? Discuss briefly possibilities and utilizing the following methods of power generation. First one is solar energy, fuel cell and other energy resources. Describe the types of solar power plant. What are the limitations of a solar power plant? What are the methods of direct energy conversion? These are the important questions in this episode 2. Thank you.